But Einstein's theories of special and general relativity have given us two ways to slow this flow of time down: speed and gravity. Both high speed and high gravity will slow down the flow of time. One of the earliest experiments on this was carried out in October 1971. It took over half a century for everything to come together, after Einstein's theory of special relativity in 1905, and his theory of general relativity in 1915. It was probably one of the cheapest tests of relativity ever carried out. By the early 1970s, atomic clocks were now precise enough to get sufficiently accurate measurements, as well as being rugged and portable. Also around that time, the recently introduced Boeing 747 was being taken up by the commercial airline fleets. As a result, international travel was now both fast enough so that slowing of time was measurable, and cheap enough for the penniless scientists to afford it. Joseph C. Haffel, a physicist, and Richard E. Keating, an astronomer, took 4 cesium-beam atomic clocks on round-the-world trips. They booked 4 seats, 2 for themselves, and 2 for Mr. Clock, 2 seats, each with 2 atomic clocks. The total cost of this test of relativity was $8,000, with over $7,600 being spent on 8 round-the-world tickets. The 6 of them, 2 humans and 4 atomic clocks, flew around the world twice, first eastward, and then westward. Their results agreed, reasonably, with relativity. Their initial results showed that time slowed down with increased speed. Later reenactments of their initial experiment with more sophisticated atomic clocks gave much better agreement with this theory. But jet planes are slow compared to light. Once you get close to the speed of light, about 300,000 kilometers, or roughly 8 times around the Earth, in 1 second, time really begins to slow down. A spaceship traveling at 90% of the speed of light, or 270,000 kilometers per second, has its time slowed down by a factor of 2.6. At the moment, the fastest matter, regularly propelled by human technology, are the hydrogen ions, H+, zipping through the 27 kilometers circumference of the Large Hadron Collider. The hydrogen ions travel at 99.999999% of the speed of light. Their time slows down by a factor of 27,777,778. 1 second for one of these protons is about 11 months for us. Like speed, gravity also slows down time. Imagine 2 atomic clocks on shelves, the upper one being 33 centimeters above the lower one. The upper one experiences slightly less gravity, because it is just a little further from the center of the Earth. By the year 2010, our technology had become precise enough we could measure that the lower clock, in the slightly higher gravitational field, was ticking more slowly. Of course, if you want to talk powerful gravitational fields, we automatically think of black holes. There is an enormous one at the center of our galaxy, but there's a much smaller one 3,000 light-years away. The movie Interstellar has a planet orbiting very closely to a black hole. In the movie, 1 hour spent on the planet has the people back on Earth aging 7 years. But what about traveling into the past? Well, back in the year 2009, the famous physicist Stephen Hawking hosted a party for time travelers. In 2010, 1 year later, he sent out the invitations to his party in 2009. Of course, nobody showed up. Does this prove that time travelers are too busy for parties? Or that time travel into the past is impossible? Of course not, it's just one experiment, etc. But is time travel into the past theoretically possible? Again, we haven't proved that it is, but on the other hand, we haven't proved that we can't. By the way, it isn't just you having trouble with getting your head around wibbly-wobbly timey-wimey stuff. Entering the land of theory can be a bumpy ride and do very strange things to your sense of equilibrium. So, in conclusion, the science in the anime and visual novel is really accurate, but you just have to keep in mind that some things are changed to improve the storytelling. See the Mohs scale of science fiction hardness. Despite this though, in science fiction, there are levels of right or wrong, and it wouldn't be fair to omit 80% of real and working physics or theories because of the 20% left. Even the message to the past part was considered by CERN, the real one, a while after the series ended, and of course it was purely theoretical. It's impossible to do it technically because we still have the problem of the speed of light in real life. That was when they thought they found a faster than light particle, an error, but it's an idea they thought about. To put it bluntly, the individual science is accurate, just dumbed down, but very few of it is outright impossible, and calling it pure fantasy would be as inaccurate as calling the whole thing right. Except for some parts that are just here as an obvious plot device, and anyone with a brain can and should notice it. In short, it's extremely far from being pure fiction, and if you're curious enough to Google some of the things the show talk about, and you always should, curiosity is one of the most important qualities one should have. You'll probably learn a lot of things and be surprised by a lot of our real-life science, too. Fractals and attractors in dynamic systems, or how the chaos theory apply in our world, is already quite confusing by itself. But keep in mind that some things are here in order to allow an effective storytelling. The core is still accurate though, and they don't throw technobabble randomly. Also, fun fact, I guess you watched the anime. The visual novel has a chapter at the beginning with a character explaining something like 10 theories of time travel, and some of them are pretty easy, the wormhole one, others are fairly complicated, the cosmic string come to mind, she then explain all of it with actual, if simplified for the reader to be able to understand, although it may still be too complicated if you're not into this science fiction stuff, and explain why it is actually not possible for various reasons, from the law of physics to how much energy it would need, etc. While the premise is about time travel, it is a bit more self-conscious than a lot of other works. I think even Hawking said something about it in one book, basically saying, yeah, it would work but it isn't. I don't know if I'm really clear here. Thing is, in theory, it's not nonsense and there is a working logic behind it, but it still would not work because of some real-life limitations. But a lot of the individual parts discussed are perfectly okay real-life concepts, if just dumbed down. In the end, your how accurate is certainly perfectly fitting, because there isn't a yes or no answer. The show, and the game even more so, try to use real science, and do it really often, but of course it's not perfect, so it depends of how much you're willing to let go if everything else aside is coherent science-wise. It definitely isn't purely fictional, like your random science fiction movie, and they showed their work, and obviously did quite a lot of research, but it's a bit of a mixed bag depending of what part of the science in it you're looking at, which is still a lot more than 90% of fiction anyway. And thank you for watching this video. I hope you like it, and for more content you should subscribe. More anime SF is coming.